Today's goal is to evaluate trigonometric expressions of non-key angles. This is different because we will be working with angles other than the pi over 6s, pi over 4s, pi over 3s, pi over 2s, with which we've become so accustomed. Take a look at example 1. We know that this is not a key angle because look at the ratio of side lengths. 12 over 21 doesn't simplify to something we're familiar with, like 0 or 1, root 2 over 2, or root 3 over 2 and 1/2. So this is an angle. We don't know what the measure of x is, and actually we don't care what the measure of x is. We know from using SOHCAHTOA that the tangent is simply asking us what's the ratio of opposite side to adjacent side. We know the side across from where opposite x is 12, but we don't know this side length. Well, we're dealing with a right triangle, so we can solve for that side length by using the Pythagorean theorem. We get a squared plus 144 equals 441. So a squared is 297. So a is the square root of 297. Those of you that are really paying attention know that 9 goes into 297. So you can simplify this as 3 square root of 33. Okay, well we just figured out that this side length is 3 square root of 33 units long. So the tangent of x is the opposite side length over the adjacent side length, which reduces 12 and 3. Since I'm multiplying here, I can reduce this to 4 over 1. So I get 4 over root 33, which I should rationalize. So the tangent of x is 4 square root of 33 over 33. Okay. Let's take a look at another example. If the sine of theta is negative root 2 over 2 for theta in some interval between pi over 2 and 3 pi over 2, evaluate the cosine of theta. I'm already thinking to myself, this is familiar. This is a side length I've been dealing with for a long time. So maybe this actually is an angle I'm familiar with working with. Okay, well let's break down my hints. This is telling me pi over 2 would be here, and 3 pi over 2 would be here. So if my angle is somewhere in between the two, my angle is either in the second or the third quadrants. Okay, next hint. Sine is a y value, and I can see that the y value is negative. Y values are not negative in the second quadrants, so I must be dealing in the third quadrant. Okay, fourth hint. Root 2 over 2. Well, you get those by looking at pi over 4s. Oh, this actually is an angle I'm familiar with. We must be talking about the angle 5 pi over 4. It's the only angle in quadrant or 2 or 3 that has a negative y value of magnitude root 2 over 2. So if I want to know the cosine of theta, this is just the cosine of 5 pi over 4. I figured out what the angle measure was because I recognized its y value. And, well, let's see. 5 pi over 4 has the coordinate pair negative root 2 over 2, negative root 2 over 2. Cosine is its x value. So the cosine of 5 pi over 4 is just negative root 2 over 2. One final example for today. If the sine of theta is negative 3/5, for theta is in the interval between pi and 2 pi, evaluate the tangent of theta. Now, there are a couple things that are different about this example from example 2. One thing that's different is we're just telling you which angles you're looking at in a different way. This would be exactly the same thing as saying theta is an element of the interval between pi and 2 pi, this time not including them, since you don't see less than or equal to signs. Okay, so again, we're looking at these angles between pi and 2 pi, so we must be dealing with something in the third quadrant or the fourth quadrant. Okay, this time we're also dealing with sine, which we know is a y value, and the y value is negative. Well, guess what? Y values are negative in both the third or the fourth quadrants, so we must consider both possibilities. The other difference is that this is a ratio I don't recognize. It's not a 0 or a 1. It's not a root 2 over 2. It's not a root 3 over 2 or 1/2. So this must be coming from some angle theta that, again, I don't recognize. That's okay. Let's draw an angle theta, some generic angle. Maybe yours is closer to the x-axis or closer to the y-axis. We don't really know where it is. But let's go ahead and draw an angle in both the third and the fourth quadrants. And when we draw this angle, we can draw a reference triangle by drawing a vertical line from where the angle stops up or down to the x-axis. So I'm going to make two reference triangles here, drawing vertical lines up or down to the x-axis. And now sine, guys, you remember this from SOHCAHTOA. Sine is simply the ratio of the opposite to the hypotenuse sides. So -3 would be my opposite side length, and 5 would be my hypotenuse side length. Well, this is definitely an unfamiliar angle. I'm labeling the angles that you make with the x-axis, those acute angles. It's definitely an unfamiliar angle because the hypotenuse isn't 1. It's not in the unit circle. But in both cases, maybe I want to call these theta 1 and theta 2. In both cases, I'm labeling the side across from it. The opposite side would be -3. The hypotenuse would be 5. Okay, and I want to know what is the tangent of theta. Well, tangent would be opposite over adjacent. I don't yet know this adjacent side length. I know 2 out of 3 side lengths in a right triangle. Guys, we're just going to use the Pythagorean Theorem again. I only have to use it once because I've got the same ratio in both sides. A is going to be positive or -4. And this is interesting. This side length here would have to be +4 because you moved to the right to plot this angle. Whereas this side length here would be -4 because you moved to the left to plot this angle. So when we're saying what is tangent of theta, well, the tangent of theta 1 would be the opposite side, -3, over the adjacent, -4, which is 3/4. But the tangent of that other angle I drew would be the opposite, -3, over the adjacent, +4. So it's -3/4. So you can box these in here, your answers, or you could say more generally, since the angle could be in one of 2 possible quadrants, the tangent of theta would be either positive or -3/4.